This is issue number 58 for the Kaiju Engine, where we set up the MSDF font rendering. Now the thing is, I mentioned that I've written a few game engines in C, C++, and Go already, and I'm probably going to be pulling over a lot of this font code, and that means it's going to be prime code for refactoring at some point. But it's going to be functional. We just have to add a few more things into what we have so far in the engine to get things kind of up and going. So one of the first things I'm going to do is I'm going to go over to content. I'm going to create a folder, shaders. I'm going to create another folder, textures, and we're going to put our textures in our textures and our shaders into our shaders. Go figure. And then we are going to add another folder for fonts. And I'm just going to dump some pre-converted fonts that I have already converted to MSDF. Now I'm going to go over the MSDF conversion process because we need to write that process into the engine so the engine itself can do that conversion where it takes a TTF file or whatever and converts it into a PNG that is a MSDF format for us to use. But just for this, we're getting the fonts rendering and displaying with some pre-existing MSDF fonts that I've done in previous engines. So another thing I want to do, since I'm going to be loading up a bunch of files, is I'm going to go over to the assets database. I was browsing the code and we don't need this suffix asset on all these functions. So I'm just going to cut that from those. Oops, I'm going to cut that from those. Another thing is, at least for right now, even though this is a test assets, or this is a placeholder assets, and we'll be replacing it with, say, some hash system or something like that. For now, I don't want to write content in front of every file path, so I'm going to say key is equal to file path dot join, and we're going to join with content and key, and we're just going to do that on all these calls. Another thing I noticed when I was browsing around the code is I would use the asset. This should have been exists. I was using this exists function, but I wasn't actually using the read from the asset database. I was just using file system read. So we're going to change this to asset db read. And then let's see, where was that other one? Asset db read. Let's make sure that the is it shader cache? No, okay. I think we're good. We just need to do those. And then when we go to the main, we were using the content prefix here, but now we're going to use shader, or shaders, plural. And this will be textures, because remember it puts content in front of it already, and I move these into the subfolder. Okay. All right. Now that we've done that bit of cleanup, we should be pretty good to go. Ah, yes, another bit of cleanup is in the host. I'm making these caches publicly available and assignable, which I don't really want to do. So I'm going to just take these guys, not the drawings one for now. We'll just do these three. We'll make getter functions for them. Func host. And then these are functions that return pointers to rendering dot that and return host dot that. Okay, cool. And so now we'll just change these to lowercase, and that means these will change to lowercase, and that means these will change to lowercase. And anywhere we use them, we're going to have to change them. I couldn't refactor because they're publicly accessible and they're accessed externally, so refactoring won't allow me to lowercase those. So here we can change these to lowercase. There we go. And that means in our main where we're using them, we want to do the functions. Also, I want this to be create shader. Let me change this to function call. I want this, instead of create shader, sorry, I just want this to be shader so it matches texture a little less to type each time we have to do that. Now, since we're going to be working with font or text rendering, and we're going to have 3D text, but we're primarily going to be doing 2D text on the screen. So we're going to add in a second camera, and we'll call it a UI camera. So here where we create this camera, we'll say new orthographic, standard orthographic camera, and then we want to set the position of this camera. You may recall that I offset orthographic cameras based on the width and height, so we want to take that into consideration. So we'll do host.window.width, oops, and this times 0.5, height 0.5, and we're going to do this as 250, which is currently the half of the far plane. So this is just arbitrary. We'll probably want to come back and fix that. And then these have to be matrix.float. Okay. And then we'll set our orthographic camera. Host.ui camera, set position to pause. I'll call it UI pause. This is just our UI camera in general. Now, anywhere we used camera, you'll notice that we pass in the camera to the ready frame. So we also want to pass in the host UI camera to the ready frame, which means we need to modify ready frame to have a UI camera. And that means this one has to have a UI camera. With that, we also need to set our view and projection, our UI view and our UI projection, which means we need to have those. And then lastly, when we bind them over to the shader, we want to add them in there as well. So it's a UI view location, UI projection location, UI view, UI projection. These will just be part of the global data. And then we will use them here. So UI view and UI projection. That way, inside of our vert shader, we would have something like view projection, UI view, UI projection, which we can pull now. Cool. So I think that's good for our UI camera. Also, while I'm thinking about it, I want the asset database to also be exposed. We don't have access to it outside of this, so let's make a func host asset database, capital A, assets.database, return that. Okay, cool. Another thing that I found that I needed was inside of float32. We have float32 and float34 or 64. We have the smallest non-zero, but we also need float max. Dot float32 max float32. So we'll drop that into here as well. Okay. So now we have our maximums, which we're going to need for our text font rendering. I'm just kind of going through all the cleanup stuff first here. So we have an add drawing. I want to have an add drawings, and I'm not going to make it complicated right now. I'm just going to make it call add drawing. We can optimize to do a little bit faster in the future, especially if we're going to be having thousands of lines of text. But the drawing also has the shader as part of it, so let's just kick that out and do drawing.shader, And now let's do func d drawings, add drawings. And that's probably going to be what I wanted anyways. Yeah. So we're going to have that helper function, and we no longer need to pass the shader when we're dealing with that. I think I added the view and projection for the camera, but I didn't add the UI camera position in case I need it. So let's see where this one's used. Go to this, duplicate, UI camera position, UI camera position. Oops. Duplicate this, UI camera, and duplicate this, UI camera position. And of course, that means now we're going to also have a UI camera position as part of our global data. And when we're creating the font, the letter meshes, we're probably going to want to be able to set the mesh key. If you remember, there's a key here on this mesh. So we'll want to say func m mesh set key string, and m dot key is equal to key. That way we can basically, we're going to be generating a quad, a standard UI quad, and then we want to change its key and possibly clone it and this other, and maybe some other things. So I'm just going to prepare for that. Yeah. Now there's going to be a lot of text generated, and there's going to be multiple texts kind of generated on the initialization for instancing. And that may cause this delayed create to be called multiple times, one for when we create, because we want to do it create immediately so that the clones can use it, any of the bindings that have been made for it. And then it might get delayed created again in the future. And we don't really want to do anything with it if it doesn't have any pending vertices. So we'll also add in if the length of this is greater than 0, we'll do this stuff. Okay, and with that, I think we're mostly ready to actually work on our font.go. Now, like I said, I've kind of gone and pulled the code from my previous Go engine that I've worked with, which that code came from my C++ engine, and that code came from my C engine. So it's been around for quite a long time, more than half a decade, I think, and I haven't messed with it. So we're just going to plop that code in here, and I'll go through what it's doing just to kind of re-review it and see if there's anything crazy amiss. But for the most part, we'll probably leave it the way it is and then come back to refactor later. Okay, so I pre-converted some of this stuff. We're going to go through the errors first and create the stuff that we need. So render caches is definitely something we need. Render caches.go. It's a interface for getting the caches off of the host, for example, because we can't have a circular dependency where the host relies on rendering and rendering relies on the host. So we need to create an interface for that. So type render caches struct, and we're going to be able to get the shader cache, the texture cache, the mesh cache, and the font cache, our new guy. And of course, these are functions. So let's just, also this is interface. I don't know what my fingers are doing half the time here. Okay, so that will make that render caches happy. Let's jump down to this. And these are actual shaders that I haven't pulled over yet that we will pull over. And they have order independent transparency built into them. And we don't have that yet, but that's going to be something we are going to be adding soon enough. So first of all, you saw this font caches guy, and we are going to want to add that to our host. So let's do mesh cache, let's do font cache, font cache, font cache. Go to this definition, font cache, go down here to, whoop, where is it? Here we go, font cache, new font cache. Okay, so now our font cache is set up here, and we have access to it elsewhere, which we haven't done anything with yet. So we're just going to create these default shaders that we're going to work with here. And I'm going to make it a part of assets, just some of the constants that we are going to use. So you can always move this stuff later. Package assets. We're going to have const. We're going to have shader. Actually, I'm just going to copy it. Font. So we got that one. Frag. This is the orthographic text and the orthographic frag. Shaders slash text dot vert. Shaders dot slash text dot frag. Shaders text 3D vert, and it's not going to be text 3D frag. We are just going to use this constant. I'm going to reuse it. Okay, so now our font is happy. No more errors. Okay, so what I'm going to do is I'm going to copy over my shaders for text rendering instead of content shaders. Okay. Okay, so we can take a look at these real quick. So we have the text vert. Everything up here is what you're used to. This is the structure we're expecting. Instance count is already set up. It was 5 in our basic vert. This one's going to be 9. As you see, 1, 2, 3, 4, 5, 6, 7, 8, 9 for that model. So it's a matrix. This global data is already set up. I created a helper function for pulling the model, which we can actually bring over into our basic vert here. Pull model equals pull model, and then just pass in the X offset. Cool. Where were we? Text vert. Okay. Just some helpers to just pull out those things as we need them. We're pulling out the instance data here. We're going to need, for example, the model, obviously, the UVs, because the MSDF texture is all of the font face characters in a single texture, and so we're going to have use UV offsetting to figure out where the characters are, and just so we can use the same texture for all of them. The foreground color is the text color, background color is the color behind the text, which can also be transparent. The scissor is how where we're cutting around this. We may not wind up using it. Hold on, did I wind up using it? Scissor. No, not in this one, but we may wind up using it, so we will keep it for now. And the PX range is just it's used for the sizing of the text and how to make it look a little bit cleaner. I don't think I have messed with this recently, and some of the values that I changed along the way here may make it look a little fuzzy, or some little lines around it or something like that. So we'll have to probably tweak some of that. And next, we just do our standard model view projection. We're getting the V position here because it was being used for the clip distance, which we're not using anymore. So I'll just put this in here, a little less code. Whoops, didn't mean to cut it. Here's where we do that UV offset stuff for the texture where we're finding the character, and then we're passing along some data. And then in the text frag, this is pulled from I pulled the compiler for the MSDF fonts off of a GitHub repository. I'm going to have to find it. And I pulled this shader off, and I modified it to my needs. So this first stuff is just setting up the MSDF stuff, and this is the order independent transparency stuff that I was talking about, which only happens if this define is set and we're not setting it. Inside of OpenGL, we are going to set it dynamically as we read the shader. If it needs an order independent transparency, it will generate it. Essentially, if it finds this line in the text, it will generate two versions of the shader, one with order independent transparency and one without, just in case we need it or not. Then it does the order independent transparency mojo, and then we output the colors. Oh, and in Vulkan for order independent transparency, we're going to have compiled OIT versions. So whenever we write our batch file for doing the compilation of our shaders, you're going to have a .vert, a .frag, and a .oit.frag file. And then Vulkan is going to use that order independent transparency file to know if the shader supports order independent transparency. It's pretty straightforward. We'll get to that when we get to that, so don't worry about it too much. 3D vert, it's basically just your regular old 3D with a UV offset, so same kind of thing. It's just pulling from the standard view and projection, whereas the other text vert is pulling from the UI view and projection. Okay, so our shaders are in, and now I need to go get all the fonts because I don't have any in here. Okay, copied over all the fonts. It's basically just all of the variants of Open Sans. So we can have bold, italic, semi-bold, italic, whatever, all the combinations of that stuff. So here's an example of what we're going to be using. This one is an example of what the text looks like. You'll see that I generated like umlaut characters and those sorts of things as well, and just all the basic ones. And we can change this mapping to have even more characters as we go. But for now, at least we can we support all of us Latin speaking people and some of our symbology. So this is generated with all these characters, and you can see that it's not that big of a texture. It's pretty small. That's one of the benefits. This one is 512 by 512, and we can support the rendering of those textures. Okay. Now I don't know if you noticed it before we go through this font, but we did have a shader data set up for these, the text shader data. And you'll notice it does the shader database from the previous ones, which is just a model matrix and some of the other stuff, but mainly a model matrix. We have UVs, which is 4 floats, foreground color, which is 4 floats, background color, which is 4 floats, scissor, which is 4 floats, and then we have a PX range, which is 2 floats. Now, when we're dealing with texture data, and also when we're dealing with Vulkan, we don't really want to end off on, say, 2 here. We'd want to pad it with some other floats so that we end off, basically these are vector 4s, right? Vector 4, vector 4, vector 4, vector 4, and then these combined would be a vector 4 if I put a 2 there. So we don't want to end off on just a 2. This is bad, because then if I stick another set of data immediately behind this data in the texture, that means that one pixel is going to have R and G. This is going to be the R and G value. And then the next one is going to have our B and A are going to be the model of the next one, which is no good because now we've split it. So we do want to have that padding. Now, it's annoying to add that padding to every shader data we want to create. So what can we do? We can actually build in padding directly. So we're going to go to draw instance and drop my phone. Don't know why I had it on my leg. Okay, so we can go into the draw instance directly and we can add that padding. So let's go up to, where is it? 72. Okay, so here we can have our padding. Is a int, just how much padding we're going to have in there. So padding is going to be equal to the data size mod, mod 16. So what are you mad about? Data size, capital S. Okay, so this is going to give us our remainder, essentially, which is going to give us those 2 floats at the end, which is, 8 bytes. It's going to tell us we have 8 bytes of padding. So now that we have the padding set up, we actually want to go in here and we want to add d.padding here so that when we append the data, we add that padding at the end of it. And then we have one more here. When we do the offset, we need to add in our padding there, plus d.padding. And that will do that extra bytes of padding, and those are useless data. There's nothing going to be in there. But it's going to make our program faster and less buggy. So we want that padding. And also when we get to Vulkan and we do instancing in Vulkan and we're using uniform data and we're not using textures, we have to have that padding anyways. That padding is going to be a part of the process. So might as well add it now. Now, before we finish going over everything inside of the font, let's ensure it's working. We don't want to go in and explain everything and then there's some kind of bug and then we have to wind up changing it. So let's see. I'm going to make a test font function. Drawings is equal to host.font cache.render meshes, and we'll do host hello world 50 50. This is the x and y offset 0 24 1000. I guess you can see right here what they're for. So just that color black. We're going to do black text on a matrix.cornflower blue background. And then we will do a matrix.vec31 for our scaling. Oh, I got to do the justification first. Rendering.font justify left. Rendering.baseline bottom. So this is just saying the bottom left is our anchor point for this text. Vector3 1 true, false here. I don't like adding booleans as arguments, but we may refactor that later. Rendering.font range. This is so that we can do coloring and font ranges. We don't have that yet. That's not a part of this. We'll probably get into that once we do the UI labels for text stuff. And then rendering.font regular. This is the font face. And then we can do host.drawings.add drawings. We'll stop doing our test drawing and we'll start doing our test font. Okay, let's see if we build. No, we got an error. I messed up something somewhere. Shader is null. So I'm guessing it didn't find the shader. Let's go back here to our shader. Create shader object. Let's see what we get here. Oh, we're not even getting there. Let's just keep going up the stack. Nope. Wait a second. Why would we be doing anything if we're not getting to our create shader? Means we've got a nil shader likely in the font code since that's the new code. Shader, create shader, no, dot shader. Okay, let's put our breaks here and see what we get. Shader slash text. Oh, we don't get here either. Am I missing something here? I accidentally pressed F11, which stops the recording. But anyways, while it stopped, it came to me. I actually need to initialize my font because we have an initialize function that I was in right here that needs to be called. So we'll just do it after there are no errors from creating the host. We'll do host.font.cache.init, and we'll pass in the host.window_renderer and the host.asset_database and the host, which has the caches, the address of the host, that is. Okay, so now our shaders should be initialized as part of that init flow code. So here we see hello world. There's a few lines here in artifacts. I guess we can make it larger, which will probably exacerbate it. Let's do like a 128 text here. But I'm not worried about those lines. We'll just, oh, never mind. It gets cleaner as it gets larger. So we'll worry about those lines and how to clean them up in a separate thing. We'll have a bug for it. For now, we just want the font in and rendering, and that's our main purpose. So lastly, now we've come to the end, we're going to check out what the font is doing. We can start with the render meshes here, which takes a lot of arguments. We'll probably trim that down somehow. Remember, this came from C, so it's very C-like, and everything you see here. So we can most likely goify this whole section, this whole file. But as of right now, it is not goified. So we set up when we start up, we go in and we have a root scale. This allows us to arbitrarily scale this text by, for example, a entities transform. So if we want to make this text follow an entity, we can re-render it using that text that entities model matrix that comes from the transform. This is just setting up some offsetting, and we'll see the use of inverse width and height here in a minute. We're selecting our shader depending on whether we're 3D or not. That's what this is. 3D is being passed. Next, we're going to iterate through all the characters, and I don't know why yet. I can't remember. Let's see. Yeah, we're going to go through the characters, and we are going to determine the line breaks. So there are functions for figuring out the text width and kerning and size and plain size and all this other stuff, how far below the line it hangs, like for commas or J's or G's. It finds all that information is built into the binary that we pull from MSDF. Essentially, what we're going to be doing with the MSDF is running it through the MSDF tool, which is a third-party executable. It'll generate a file, I think a JSON file, and then we'll convert that JSON file to binary, which we'll use internally here instead of reading JSON. So essentially, what we will do in this first section is we're trying to go through the text, and we want to render each one of those or not render. We want to prepare for rendering each one of those. We want to get the mesh. We want to get the texture. We want to set the shader. We want to set the X offset because obviously, like let's say this C was at 0, the U is to the right of it, so it moves to the right. So we're essentially setting all that up. We are doing a special thing for a line break. And also, if you remember, we pass in a max width. Here it is, max width. So there's some magic code down in here that will do a word break. So once you reach or exceed that max width, it will line break and then start the text on the next line. So that's what some of this stuff is doing. Next, we're figuring out where we start on the x-axis given the justify. So if the justify, for example, let's put this at 0, 0, so it's in the bottom left corner. Let's make this a little less screamy. We've set this justify to the left and the baseline to the bottom. So it's down here in the bottom, and notice that comma is pushing up the text a little bit there. Now, if I say that I want this to be center, then it's going to figure out the width of that line. And the width of the line is like I forgot what it was. It was 1,000 or something like that. So that width is somewhere over here, so it's going to center the text in there. So if I set this to like 1280, what is that, 720, 1280? I can't remember. Um, let's do justify right, which will make that a little more clear. Let's just make this a really, no, that's fine. I'm re-educating myself on some of these patterns. So the far right edge is going to be right over here. So I think this window is 1280 by 720. So this is the 1,000 mark. So if we were, if we were to change this to 1280, we might get a better result here. There we go. So that's the right hand side, and then justify center. That's going to center the text in the window here. And then the baseline, we can do bottom, we can do top. This is essentially that vertical anchor of the text. So it's going to be off the screen right now because we said top. And then if we say center, it'll make it a little more clear what happened there. It's going to be halfway down the screen. So it's moving, the baseline is now at the center, and it's going to be there at the bottom. So this gives us a lot of control over how we render it, where it's rendering, all that sort of stuff. That's what the justification and the baseline is. And then we go through the actual code of pulling out the literal X and Y positions that each one of these characters is going to be at. Once we've set up all of that, we have one of two options. We're going to pull from cache. So if we're using instanced, which we are, you'll see here, instancing is true. Instancing means that it's going to do this whole thing in one render pass. It's going to do all the text in one render pass. So since we're using instancing, we're pulling a cache letter, which happens in the initialization. We can go back and look at that in a minute. And if we are not using instancing essentially here, or if we tried to hit the cache and we couldn't get anything out of the instance for some reason, we go and we actually build out a mesh that we're going to be using. And we set up what its UVs are and all that stuff. Otherwise, if we got a cached mesh, we're just going to set up the model matrix of how we're going to place it. Or this is the matrix that's multiplied by the entity transform I think we did in the last video. So this is offsetting and scaling and setting up the actual quad in how it looks for that instance. Then we assign a bunch of the shader data, the foreground color, background color, pixel range, UVs. The scissoring, which when we see this as a scissor, the negative max and the positive max, that means that there isn't a scissor. It just goes, there's no cutting of the render. We set the model to the model we've modified, set up the font. This is just an array of drawings. And then we basically get the information on moving along the X to the next character, or, and we're also getting what the max height is. So when we go to the next line, we know how far down we need to go. And that line height might be one of the refactors that we mess with, is this line height and what we're doing with this, something like that. And then we're just kind of moving on to the next character. So there's not really a crazy amount going on in the render meshes. It's just taking the input data and plotting the meshes onto the screen. Other than that, we have our justify constants. We have a font face string, which it just has some helper functions to determine whether it's bold, extra bold, italic, getting the string. Here's all our constants for our font faces. You saw that we used that here, font regular. So there's all our constants for our Open Sans font faces. Of course, this is a prime area for refactoring because it's directly in here, and if we want to use other font faces, we gotta compile them, and of course we can make them. That's why you can pass it in. You can just make it, but having these embedded may not be the best. This is the metrics that we have inside of the binary. We have the EM size, line height, ascender, descender, underline Y, and underline thickness. This is the font that this is the data we're getting out of the binary and the order we're getting out of it. This is the font range, so we can bold and italic certain ranges. So we can have a string of text, hello world. If we wanted to italicize and bold the word uh, world, we could do that by setting the start character and the end character um, in its linear array form, and we can set the bolding just for that. Then we have also as part of the font pen character, we got the letter that we're dealing with, the advance, which is how far you need to move it, the plain bounds. This is the bounds within the bounds that contains the letter, and this is the atlas bounds where it is in the atlas for that UV for assigning where the UVs are. And then this is just the kind of the cache, the setup for our cache, like the texture for the individual font, the width and height of that font texture, the metrics for it, all the letters that make it up, because you can have different letters for some fonts, as you know, don't have certain characters, so this just has a mapping of all the characters available. And then the cached orthographic and non-orthographic versions of those. This is the cached mesh there. Has the mesh, px range, which we use in the shader, which I said we'll tweak to kind of fix up those lines and the thickness of the characters and that sort of stuff. UVs for that mesh, the UV offsets, the shader that it uses, the texture and transformation. Then we got the font cache. This is the cache that has access to all that stuff we just talked about. This is the shader data that we pull straight from text. So this matches one-to-one with this stuff here that we're pulling. Model, UVs, foreground, background, scissor, pix range. Model, UVs, foreground, background, scissor, pix range. They match up directly. This is the required function for it to satisfy that that interface. This is just EM sizing. This is useful for working with. I forgot what EM stands for, but essentially instead of pixels, you can. This is inches or centimeters on the screen, I think, or something like that. It's related to it. Create the cache, width, height, atlas stuff. This is getting the font character. And if we don't find the character, say we request a character rather than crashing or whatever, we have this default character that's a part of all of our compiled atlases, which is just a large kind of square to just put a blank box there saying missing character. Then we have our helper function that we used in that rendering, which tells us how many characters fit within a certain width. So we give it the font that we're using, the string that we want to check, the maximum width, in this case 1280, and the scale of the font, and we say how many characters fit in this width before we need a word break, and it does the line break checks and that sort of stuff. We have the cached mesh letter. This is just being able to pull from the cached letter, or try to. So that's all that does. Create letter mesh. This is used for caching the letter. You can see it goes through and it actually uses those atlas bounds and all that sort of stuff for setting up. It's pulling the binary, getting the atlas bounds, and setting up, the UV offsets and the mesh sizes and all that sort of stuff. Init font. This is just called to initialize a font. We give it a font, it initializes it by reading all of the binary data that is created from the MSDF binary conversion tool that we will eventually make. Just reads all that binary data and sets up the font, caches the letters, all that sort of stuff. This init just calls that cache for each of the fonts that are listed way above. Render meshes, we already talked about. This is the primary function for the whole magic. Measure string, this is useful for saying, giving it a string and measuring what's the width. If I give you hello world, and this is the scale of the text, and this is the font face, how wide is that? That's essentially all this is doing. Then we have measure string within, same exact thing, except we say, given this max width and this string, what is the width and height of the box? Now, you just because you wrap around doesn't mean you're always going to have the max width, because the wrap is the width of a word. So the width needs to be returned to tell you um, what is the very bare minimum box required to contain this text given this width when we go to render it. That'll be useful for us later for many things. String rex within new. To be honest, I don't remember what this does. It's used in point offset within. So I think this is just creating a rectangle for every character. So it's giving you every rect because it's returning an array and it's going through all the characters. So I think it's just giving you essentially all those rectangles that this string would make up. Might be useful for when you have some text and you want to click somewhere in it and you want that cursor to move there. We will be doing an input field, so I think that's what I added it for. Line count within, so you give it this is the same as that where we count that box. We calculate the box and we figure out how many lines this text given this max width is going to be. So if I give it a huge string, it's going to tell me there's, I don't know, 10 lines that make up this whenever we do the word rep. This looks like it. Oh, this probably takes into consideration. What are we on? 574. This probably takes into consideration the new line. Yeah. Okay. So it'll also consider new lines there for the new lines for the line count. Measure character. You can give it a single character, get the size of that character and width and height. Point offset within. I think we give it a point. Yep. And then this is essentially what I was talking about, where you give it a point somewhere, you click, it figures out those rectangles, and then it determines where we're at, which character we're. As you see, it's an int. It's going to tell you, like, if I clicked here in text length, it's going to say it's 1, 2, 3, 4, 5, or 1, 2, 3, 4, and assuming we're not talking about this whole line here. If we're talking about this whole line and I clicked here, it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It'd be 12. So that's what that does. So that's all the font code kind of laid out. I know that was a lot of explaining and not actually coding, but as you could tell, this would take a couple hours to kind of go through and hand code, and I would just be doing the same thing I did before because I know it works. I've used it and completed published projects, so I just want to pull it over and work with what we got and then refactor it into something better and more improved as we go. And I think that about wraps it up for text. Now that we have text rendering, we can work on, I don't really want to work on the MSDF generation code yet. We'll have that as a separate issue. We'll do later for generating those because we have text to work with for now. We might move on to order independent transparency or something similar to that. I am, like I said, working on porting a project that I wrote in my C engine, which used this font code and some other stuff. And so the things that I need to get it going, because I'm using this engine to rewrite that entire published project. Published, it's live, it's working, so I'm rewriting it in this engine, so it'll be a proof of concept. This engine will be running something that's published as soon as we get it to the point where it can. So as I'm working on that, I come up with things that I need to continue porting that, and so we do them here. So some of the things that I need is I need my very rudimentary UI system, which is just a panel that can scroll and a label with some text. And I also am eventually going to need some Android stuff and some other stuff. So as I need it, I'll be adding it in. And like I said, the point of this engine, first and foremost, is to be able to write your game from scratch just in code without an editor and be able to publish that. And then an editor is going to sit on top of it. So anyways, that's a lot of rambling. I think that's it for this for now.